At the top of page 2, we have some properties of summations that can be handy depending on what we're adding together. Help simplify things a little bit. But I don't think it's important for us to take the time on those right now, so just note that those are there. So to find the sum of an arithmetic series, which means we're adding all the numbers in an arithmetic sequence together, well, not all the numbers, because we have to end at some point. We can't do an infinite arithmetic series. We can use this pattern, which legend says was discovered by a young schoolboy named Gauss, who later became a famous mathematician, which is who the Gaussian elimination, which is another name for row echelon form, is named for. Anyway, there's other things he has named after him too. But the idea was, instead of adding each individual number together, we add the first and last numbers together, and then the second and second to last number, and the third and third to last number, and each pair of numbers adds up to the same sum. So instead of adding 100 individual numbers, we have 50 pairs of numbers that each add up to 101. Multiply that out, and we easily have the total sum of all 100 numbers. So here's the general formula for that. The sum of n number of numbers of an arithmetic sequence can be found by taking the number of numbers divided by 2, that number times the sum of the first and last numbers added together. Okay, let's go through some examples. Find the value of the arithmetic sum k equals 1 to 12 of 4k minus 5. Okay, so what we did on the previous problems when we were finding these sums is we just found all the numbers, in this case it would be 12 numbers, and we added them together. I mean, I guess you could kind of do that, but you don't need to. All we need is the first number and the last number. And the number of numbers. Well, that's easy because look what we've got right there. The number of numbers is 12. So we've got n. We just need the first number, which is going to be found by taking 4 times 1 minus 5, so negative 1. And we need the nth number, which in this case is the 12th number. So 4 times 12 minus 5, so that's 48 minus 5, which is 42. Okay, so we have all 3 numbers we need for our formula. Did I subtract wrong? 43. I guess I was thinking that 42 is the light, the F light here, sorry. Alright, so to find our sum of 12 numbers, we take our 12 numbers and we put them in pairs, so divide by 2. And those pairs consist of the value we get when we add the first and the last numbers together. So we're taking 6 numbers that add up to 42 each. Oops. Multiply that together. See, that's 24 plus 40 plus 12, 252. And we have a sum of 252 without having to add the 12 individual numbers together. We use them. Let's look at the next. The first term of an arithmetic sequence is 15. So a simple, I'm just going to kind of start making a list. A simple one is 15. And the 10th term is negative 12. A sub 10 is negative 12. Find the sum of the first 10 terms. Then find the sum of its first 20 terms. Okay, so they gave us exactly what we need to do the first 10 terms, because that would be for n equals 10, right? Still with our n equals 20 in just a moment. So let's start with our first 10 terms. So the sum of 10 terms would be 10 terms divided by 2. And we add our first and our last numbers together. So 10 divided by 2 is 5 times 3. So that would give us a sum of 15 for the first 10 numbers. So we just double that, 30 for the first 20 numbers? I mean, just think different. Probably not. Not unless the sequence was exactly right for that to work. All right, so now what we need to do is think about this for the 20 numbers, which means this is a little more complicated because we probably want a formula. So we need to figure out what's happening here. So from 1 to 10, that's 9 numbers. How far does this go from negative 12 to 15 in those 9 numbers? How many values are there in 9 numbers? It's making a jump of 27, right? In 9 numbers. So that's a jump of 3 per number. Why is it always 3? So that is our common difference. We can use that to write a formula. So that means that our a sub n formula is 3 times n. Well, now we need to figure out what the first number needs to be. Oh, I've done something wrong here. Haven't I? Oh, I was suddenly thinking it should be a negative 3. Yeah, right. I did do that wrong. Technically, we should have started with the number that is further down the line, so the negative 12, and subtracted the 15, which means it would have been a negative 27, which gives us a negative 3. It's always good to stop and make sure what you're doing makes sense. If I'm going from a positive 15 to a negative 12, I'm subtracting 3 each time, not adding. So D is negative 3. Do you see how I found my mistake? Okay, so that's going to be a negative 3n, and I need the number to start at 15. So what number do I need to put on this so that when I subtract 3 from it, I have 15? 18, right? So there's my formula. So what's the point of having the formula? What do we need to do the second part of this problem? We need the 20th number, don't we? So we're going to find a sub 20 by going negative 3 times 20 plus 18. So negative 60 plus 18. Help me out with this. Negative 60 plus 18 is that 42? Negative 42? Somebody check my math. So s sub 20 would be 20 numbers divided by 2. But this time, the first number is 15. The last number is negative 42. So 10 numbers times the difference between negative 42 and 15. Negative 27. I think that sounds right. So that means that that sum is negative 207. I have these problems written on papers that I just printed out. So I will check my answer really fast. Yes. Yep, so far so good. Okay, now let's look at example 5. I don't know if I can read over what I wrote there, so let me get it out of the way a little bit.